In January 2005, NASA launched a unique probe into space to find out where water on Earth might have originated. Named Deep Impact, this probe traveled 270 million kilometers to get close to a comet, which held secrets scientists had been seeking for centuries. Welcome back, viewers of Historical Stories. There is only one known place in the entire universe where human beings can survive: Earth. It seems as if Earth was created specifically for us. It has all the elements essential for life: water, food, and oxygen. Though the universe is vast and might contain other habitable planets, Earth is the only one we know of where humans can live without assistance. But about 5 billion years ago, Earth didn't even exist. The place where Earth and our solar system are now located was just an edge of the Milky Way galaxy. Before Earth, there was a huge cloud of dust and gas in this region, known as a molecular cloud. This cloud consisted of dust particles, including sand, silicon, and various metals, and was created from dead stars. In the early universe, stars burned through their fuel, exploded, and scattered particles across the universe. This cloud, which could only be captured by the Hubble Space Telescope, stretched about 100 light-years across, 6 million times the distance between Earth and the Sun. The cloud was a birthplace for new stars and planets. The force responsible for forming stars and planets out of this cloud was gravity, the same gravity that exists in space, even though we can't feel it. Particles in the molecular cloud began clumping together due to gravity, with larger particles attracting smaller ones. As they collided, energy was generated, heating the cloud's core. For millions of years, this process continued, and the core became larger, spun faster, and grew hotter, eventually forming a massive ball of fire, the Sun. The remaining molecular cloud began orbiting the Sun, and its particles and gases eventually formed the planets, life, and the moons orbiting those planets. This process was a mystery until recently. The idea of stars forming from a molecular cloud was first proposed in the 1700s by German philosopher Immanuel Kant and French scholar Pierre-Simon Laplace, though it was just a theory at that time. Between the 1920s and 1950s, more advanced telescopes allowed scientists to see inside these dust clouds. With the invention of radio and infrared telescopes in the 1970s and 1980s, scientists could finally observe new stars forming within molecular clouds, confirming the theory. But how does this process start? In March 2003, an experiment aboard the International Space Station provided an answer. Astronaut Don Pettit conducted experiments with various objects, including salt in a plastic bag. After some time, the salt particles clumped together in the absence of gravity, demonstrating how particles in space attract each other and form clusters. Scientists believe the particles in a molecular cloud clumped together in a similar way, starting the process of planet formation about 4.5 billion years ago. When these clusters became about a kilometer in size, they developed their own gravity, attracting nearby particles like a vacuum cleaner. Over millions of years, clusters of particles merged to form 20 planets orbiting the Sun. Due to their size, the gravity of these planets began attracting each other, and collisions between them eventually formed larger planets like Venus, Mercury, Mars, and Earth. This new Earth wasn't yet habitable, it was hot and molten from constant collisions. It needed to cool down and face one last challenge: solar storms. Solar storms damage atmospheres, preventing life on planets like Mars. However, Earth's core protected it by generating a magnetic field that repelled the sun's harmful radiation. Earth's core, made of molten iron, created this magnetic field, which extended up to 370,000 kilometers and blocked solar radiation. This field also created auroras, or northern and southern lights, at the poles where the field is weakest. Once Earth cooled, a massive collision with another Mars-sized planet named Theia caused Earth to tilt 23.5 degrees, creating seasonal changes. This tilt, along with the formation of the Moon from Theia's debris, allowed for tides, which provided nutrients for marine life. Seasons and tides supported diverse ecosystems, which eventually led to the evolution of life on Earth. But where did water on Earth come from? In 2005, NASA's Deep Impact Probe was launched to study the Tempel 1 comet. On July 4, 2005, a copper impactor collided with Tempel 1 at 38,000 km per hour, creating a crater. Spectroscopy analysis revealed that water existed within the comet in frozen form, showing that comets contain water. Scientists believe that Jupiter's gravity, due to its massive size, pulled comets from the asteroid belt and directed them toward Earth, delivering water to our planet. Analysis of zircon minerals, which require water to form, indicates that water first appeared on Earth about 500 million years after its formation. Earth's formation, the collision with Theia, the tilt, the creation of the Moon, and the delivery of water from comets due to Jupiter's gravitational pull all contributed to making Earth a place where life could thrive. But there was still one final piece missing: oxygen. Tell us in the comments how you think oxygen appeared in Earth's atmosphere. We hope you enjoyed this historical stories video. Like, share, and leave your comments. Thank you for watching, and see you in the next video.